this demonstration, I want to show you a very cool thing and a problem that I found in a production in one of my clients. And then when I was troubleshooting the problem, I came up into the very interesting things that related to memory usage, the buffer pool data cache usage, and then the checkpoint and lazy writer operations. So, and then tempdb as well. So it's a mix of memory problem, but it started by the customer complaining to me that sometimes one of his queries his query was taking a lot longer than usual, and then as always that was only happening occasionally. So that wasn't a not something that was happening every time, every minute, but it was like a once per day sometimes, and then sometimes several times per day. So let's go and see how I created my own demonstration and repro of the problem. And then yeah, I will also show one thing that I think should be different. But let's go to the demo, and you understand what's going on. So I will start by, as always, using a code cache. So I'm going to restart my SQL Server. So that's a 2017 version. All right, let's wait for it to come back. Okay, starting the server. Come on. There we go. And then just to check if we are back here, let's see. Okay, we are connected. And then, oh, let me zoom it for you. And then minimize this one. Okay, and then I will run those tests with 10 gig of memory, so the max server memory is only 10. Okay, and then I created my own database to run in those tests. If you want to do it using the script I will provide, you can do it as well. So I'm going to create a database here in my C drive, which is an SSD. So I won't run it again because the database is already there. And then into this database I will create one table called the products one with 5 gig. I already did it, so I won't run it again. And then there's another table that I might use. I don't think I'm going to use in this demonstration, but that's the customer big table. And let's start by, I don't really need to do it because I just restarted the server, but anyway, let's start by creating a table. So just created a table, dummy table with one column, and I'm going to insert some data there. And then let's start by looking at the fact that when you insert the data, you could have like a regular logged operation, or you could have a minimum log operation, right? So that's a point I want to show here. And then, so just to show you the difference, so here's the insert that I'm going to run. Insert into the table, and then I think 5 million rows into this table, right? So that's it, nothing else. And then I don't want to run it in parallel, running everything serial to make the tests easier. And then truncating the table here, I just created, but just in case I don't want to rerun it, truncating the table and then inserting the data every time. So let me run it. And then before I run it, I'm capturing the bytes written, and then the bytes written for the data file and then for the log file. Okay, and then I'm saving it in a variable, and then I'm going to compare here later to see what changed. So what I'm trying to do here is how much data I wrote into the data file and how much data I wrote into the log file. And that's a key thing for performance, right? Let me run it. it might take up to 40 seconds. And regular insert into the table, and then a bunch of rows. And then because I'm not using the tab lock here, that's a regular logged operation. So you see that I'm going to write a lot of data into the log file. So if you look at here at the resource monitor, you can see that I'm writing, and then I'm also writing to the data file. So about 200 megabytes per second in the SSD. And then the query ran. So I wrote about 2.4 gig of data into the data file and 3.2 gig in the log file. And then the benefit, it took 37 seconds. And then the benefit of the minimum logged operation, so that's the only thing that changed here in this second query that I'm going to run, the second test, is that I'm using the tab lock, and that's going to enable the minimum logged operation. Okay. So let's see, and then the minimum logged operation is going to write log file. And then if I come back here, now than before. And let's see if hopefully this is going to improve the performance. And then you see now it took only 21 seconds to run, so this is faster. And why? That's because of the log data that I'm not writing anymore so much log. So that's the minimum log operation. But that's a known thing that many people know. But one thing that I found curious was that, look at here, we are writing 3.1 gig of data into the data file. And then I was wondering, why am I actually writing into the data file like a physical write IO operations if checkpoint is not running? Because you know, who writes data from the memory? Because remember, everything is written in memory in SQL Server, and then there are processes that grab those data in memory, and if they are not in disk, the process is going to read the dirty page from memory and then persist it, flush it in the disk in the data file. And there are common, at least the most common processes that do it are the checkpoint and then the lazy writer. And then since I do have data written into the data file here, does it mean that the checkpoint ran? And actually, if we come back here, in the next demonstration, I'm actually going to check if checkpoint is really the one writing the data into the file while the query is running. And then to be able to do it, I'm going to enable the trace flag 3602 that it's going to write the checkpoint information into the error log. So let's run the same query again, and then check the error log. Let's see. And no messages about the checkpoints in the error log. The reason why it's that, let me show you. So you see, let me zoom it. Nothing regarding the checkpoints. And the reason it's that because the process that is actually writing the data into the data file, it's the eager writer. And then eager writer, it's a different feature. It's a new it's not a new feature, but it's a feature that it's used when you're writing pages from a bulk logged operation or a minimum logged operation, which are most of them are bulk logged as well. And then if you want to go and read more about it, the Bob Dorr, he blogged about it. And then the idea here is from the eager writer is just to avoid the checkpoint processes to have too many pages to flush, right? So since bulk logged operations are most likely to write a lot of data in the data files and modify a lot of pages. Instead of waiting for the checkpoint to flush all those pages, eager writer, it's actually going to do it now. There's another trace flag that you could enable, which is the 3917, that you could see that eager writer, it's actually the one kicking in and writing the data into the MDF. The query, let's look at the log file. I already have it here pasted, but I see a lot of messages in the error log, and then I have a summary here, which pretty much tells us here. See, so eager writer wrote a lot of pages. So yeah, so but that's okay. So far so good. Many people already know about it, but the problem starts now. And let's say I have the following scenario. Starting by flushing the cache, okay? And then I'm going to read two tables. The products one, this is going to put 5 gig in memory. And then the tab case 2, it's going to put, I think, another 3 gig in the memory. Yeah, total of data cache used for the DB case 2, it's 8 gig, okay? That's because I'm looking at the buffer descriptors here. And then if you look at here at the statistics IO, you notice that since it is the first time I'm running, because I ran the droplet buffers, this is actually reading the data from disk. So those are physical IO operations. Again, so far so good. I just want to run it to populate some data into the cache. And now let's consider I'm actually going to run this query. I'm going to open a new session here. And then the difference here is, the only difference is that now instead of writing into a regular table, into a user database, I'm actually writing the data into the tempdb database. And now I'm using into clause, but I could be using the insert into with the tab lock. That would be the same, exactly the same behavior. But so here's what I want to show. Here's what we have so far: 10 gig of memory available, 8 gig used for those two tables that I just read, and then now I want to insert some data into a table into the tempdb. And this insert is going to insert about 3 gig of data, okay? So let me run it. And the first thing you're going to notice is the performance. So that's a lot faster. This is only taking 5 seconds. So let me come back and ask you, why is it so faster to write into a tempdb table exactly the same data that it took a lot slower to write into a regular table in a user database? And the reason that tempdb writes are faster, it's because of the eager write process. It's actually, sorry, I want to highlight this one. The eager write process here, it's not running for the temporary objects. So objects inside the tempdb are, in the Microsoft words, are relaxed. The eager process is relaxed to don't write those pages into the tempdb data file. And why not? Because, you know, the whole reason of writing dirty pages into the data file and into the log file, it's to recover the data later, right? So, but in the case of the tempdb, there is no reason to recover the information in case of a SQL Server restart, reboot, because the tempdb is going to be recreated. So, and that's one of the reasons why there is no checkpoint for tempdb. well, at least no automatic checkpoint. So the frequency of the checkpoints for tempdb, it's a lot different. It actually only runs when the log file size it's greater than, I think it's 70%, and then checkpoint is going to be executed. And you can also, of course, run the manually the checkpoint. So use tempdb and then write checkpoint and run it. But the automatic checkpoint is not going to run for tempdb, and it makes sense to don't do it because we don't want to recover the data. But now here's what's going on. And then this relax of Eager Writer, it's only available in 2014. It's actually available on 2012 as well, but it depends on the version you're using. But and then here comes the scenario I got into my client. So if we look here, sorry. So actually, you see that I dropped the table, but I'm actually going to close this session. So the table, it's not used anymore, it's not available, right? And then, look at here. If we query the OS buffer descriptors now, you notice that there are a lot of pages in memory for the tempdb. So those are the pages related to the insert that I just ran, right? So the insert created all those pages. They're all in memory. They are all dirty pages because the eager writer did not flush them to the data file, and then checkpoint did it as well. But they are here. They are allocated. They were allocated. And then notice that the DB case 2 that was actually using 8 gig, now it's only using 5 gig. So that means when you ran your query to insert a lot of data into the tempdb, what happened? It's that tempdb, that process had to insert those rows in memory, but the memory was not available. The available data cache was not enough, so it has to remove some of the pages from the cache, and then those pages were from the DB case2 database. Okay, so that means that probably the PLE, when I ran it, you see this is the page life expectancy counter, and then when I ran the insert into the tempdb database, PLE dropped because it has to drop to remove some pages from the cache. Okay, and then that probably means that if I run a select again into this table, which I did, where? Here somewhere, so hold on. My bad, it's which I did here. Do you remember that I started by running the droplet buffers and then reading the table, and then it did the physical reads. But if I do it now, I would expect it to read those 5 gig from cache, right? But that's not the case here, because you saw that tempdb actually needed those pages, and then it has to remove the data from the cache. And then that means if I read the table again, that's going to trigger some physical IO operations now, because it has to read from the disk again, because the data is not available in memory anymore. Which is okay. If we come back here there again, let's see how much time did it took. It took only 3.5 seconds to read the table from the disk file, and then put it in cache. So if I run it again, I would expect, if it has to read everything from disk, I would expect it to take about 3 seconds again, right? So let me run it, and that's was happening in my client environment. So you see, it already took 5 seconds and it's still running. And while it's running, look at what's going on here. I'm going to do this session here, and I'm going to look at the waiting tasks and then the IO pending requests and check this out. So my session, it's actually the 51. It's waiting on the sleep, okay? And then look at the pending IO operations. There are a lot of IO going on in my tempdb file. Let's go to resource monitor here. Look at here. A lot of writes on tempdb going on in the MDF file. So what's going on? So I'm trying to read this table. There's not, those pages are not in memory, so I got to read them from disk and put them in memory. There is no memory available because I'm using everything now, the 10 gig available. And then, because there is no memory available, some of the pages will have to be removed to do space for the new pages. And then the pages that are actually being removed are those pages related to the tempdb operations. But those pages are actually dirty pages, so they can't be removed. But we need first to flush those pages and clean those pages, and then remove them from the cache, and then put the page, the memory space, into the free list, which is the process that LazyWriter does, right? And if we come back here, you see that while the query was running, LazyWriter kicks in, and then LazyWriter is removing those pages, is actually flushing those pages, and then removing them from the cache, and then putting the page into the free list, right? So that's a really, really weird situation. And then I'm going to explain why I think this is weird. First, I'm trying to read a table which was in cache, but is not in cache anymore because of the tempdb table pressure, okay? And then caused by the, in this case, by the eager writer that did not took place for tempdb operations and minimal logged operations. And then I will repeat, I'm trying to read a table that was in cache, and then it took 53 seconds to do it now. If I run it again, look at what's going to happen. 1, 2, 3. Still, it's still reading the data from the disk. And if we come back here and look at the IO again, there we go, more IO going on the tempdb file. Why? Because when I ran it, LazyWriter was called, and then LazyWriter found a lot of pages, dirty pages, and then LazyWriter, it's now working like crazy, trying to remove all those pages from the memory, and then before it does it, it has to flush the page to disk. But actually, this page has no use anymore, right? Because I destroyed the table. The session that created those pages doesn't exist anymore. The table doesn't exist anymore. But the page is there, it's allocated, it's dirty, and then LazyWriter will just read those pages, and then it's going to flush it. Why is it going to it's flushing it? I don't know. I don't think it should do it. If a page doesn't belong to a living object anymore, it should just, even that the page is dirty, it should just remove the page, clean the page, not flushing it to a file, and put that page into the free list, right? Why do we need to flush it first to then put in the free list if the data that I'm flushing, it's not going to be used anymore because the object doesn't exist, right? You see? So that's a very, very interesting case. And then that's just the way it works. So let's go into recap. It's faster to insert data into tempdb because eager writer it's relaxed, and then pretty much you have an insert in memory, and then it's going to remain in memory because checkpoint's not going to run for tempdb. So that's why it's a lot faster. So you could benefit from this if you have an insert into or select into. You could try to create the object into temporary tempdb database, and then your inserts are going to be faster. I think that's a perfect case for staging, for instance, when you can easily recreate the table in case of the system restart. So your populate your stage environment, it's going to be faster. But then that caused the problem because then tempdb was using a lot of memory, and most of those pages were dirty. And when you have a memory pressure, which usually we have everywhere, right? We usually have 2 gig databases running into a 64 2 terabytes database running into a 64 gig memory environment. And then in those cases, you always have a memory pressure, especially in the buffer pool data cache. And then tempdb, it's taking some of those pages from cache and then using for those in-memory objects. And then even when you drop those objects, lazy writer, it's actually flushing those to the tempdb data file. And while lazy writer is running, if you are lucky to be the one that triggers the lazy writer, because lazy writer I think runs every second, but one query, one thread can actually call lazy writer, so wake up lazy writer. And if you are not lucky to be one of those, you see the query now took 14 seconds, and if I run it again, it's finally reading the data from all of the pages from the disk. But you saw that occasionally the query was taking longer, and that's because lazy writer was your query was put to sleep while waiting for the lazy writer to put some pages into the free list and come back to your query, so we would be able to read the data from the table you want to read and then put it in the cache. So interesting situation. I hope you followed me, and if you have questions, please let me know. Write a comment here in this video, and yeah, I'm definitely going to ping Microsoft and see what they will say about the lazy writer actually flushing the pages that are related to an object that doesn't exist anymore. All right, and this is it. Thank you. Bye bye. See you soon.